All right. So before we go back into object-oriented stuff, get back to where we okay, this is kind of the zone we were in. All right, so let's talk about the final exam first for a few minutes, and then we'll cap off our object-orientedness. Time for the final. Well, so what I'm going to do is the same thing as the midterm. I'll have the exam up by Monday morning next week. It'll be online. You can take it whenever you want. I'll give you plenty of time to do it. You do need to complete it in a single sitting. It's closed book, closed note, closed neighbor. I expect the work to be your own work. What I will do is I'll ensure if you want to take it during the normal scheduled class time, I'll make sure that I'm live to answer any real-time questions while you're taking the exam if you choose to do that. Otherwise, you can do it whenever you want during the week. I'll just need it in by midnight on Friday so I can grade over the weekend. So you can do your own time management, whatever makes sense for you. Anybody know off the top of their head what the official time is for the exam? Let's see. So we are a Tuesday, Thursday class, and we met for the first time before 8:45 a.m. So, ooh, man, we should meet in person for that one. It says 7:30 a.m. Thursday. Is that right? The class that meets on a Tuesday. Our first meeting was before 8:45, and it's 7:30 a.m. Thursday. So official meeting time is 7:30 a.m. Thursday. So I will be live on Zoom / Slack between 7:30 and I don't know, 9:30-ish, 2 hours, something like that. I don't expect the exam to take that long, but I'll probably put the timer on the exam at like 3 hours or something. So what I typically attempt to do is I attempt to write an exam that takes around an hour. And then students, I don't know how to read grammars like they did in the, in the first exam, and it ends up taking more. But the intention is to have an exam that takes about an hour to do, taking the time pressure off. You have a 2-hour time slot for the final exam, and I'll probably set the timer at whatever 3 hours for the final. But you do need to do it all in a single sitting. So it will submit the exam for you at the end of that 3-hour time limit. Or if you walk away, well, then you'll be sending me an email wanting me to open up the exam again, which won't make me happy, but it also will reset the entire exam. So you'll be starting from scratch. Now that always happens. Sometimes the student has trouble starting the exam, like they start it and then something crashes or whatever, and they can't get back in. But so don't not reach out if you had an issue trying to take the exam, but don't do the exam and decide that you're not happy with how you were doing, and go back and study some more for it. We'll work on the questions offline and come back and take it again. So that's the exam will be my usual 10 questions, short answer. There'll be programming, there'll be explain this, explain that, no multiple choice, no fill in the blank, none of those kinds of things. Go ahead.
That being said, will grammars be at this final?
Grammars will definitely be on this final. So you have to be able to read grammars. You'll have to be able to write a grammar. You know, if I say, you know, give me an example grammar for the language of numbers or something like that. Let me just check this chat real quick. Yeah. You should be able to do that. You should be well versed in what a grammar is, what a production is, all those things. I'll go through the slides here and kind of point out what's important. The emphasis will be on the things since the midterm, you know, but we've just continually been growing on our what we've been working on. So, you know, that's sometimes hard to differentiate, but I will expect a stronger skill set since the midterm than before the midterm. But grammars will be on there. You will have to read them. I will give you a grammar and tell you to write something related to it. Since the way Blackboard presents questions, like if I were giving you a normal exam, I'd probably put a couple of grammars up at the top and then have you reference those. But what I would do on the exam is I would give you the grammar on every question that you needed to use that grammar for. So if I was having you do something with the, you know, the previous exam, I think we had the binary tree grammar that everybody struggled with. You know, any question that dealt with that, I would give you that grammar as part of that question and say, given this grammar, yada, yada, yada. Okay. Quick reminder, remember Bible homework? I think Blackboard shows it as being due by midnight this Friday. I'll take it by the end of next week if you need to time management or whatever. So I'll try to remember go in and update that, but otherwise don't worry if it marks you as late. I won't dock you points. I'd probably encourage you to try to get it done by the end of this week. That way you leave next week clean for doing your final exam activities, but you do whatever you need to do to best manage your time. Because I know some teachers might have some big projects coming up due at the end of the week here. Okay, and I have my usual policy. If you do better on the final than you did on the midterm, I'll replace your midterm exam score. And that'll actually be hopefully helpful in this class, because I know several people did not do as well in the midterm as they maybe typically do. And hopefully your understanding of grammars and stuff is a little bit better now, and you'll be able to make up for some of those bulk lost points. So let me just fly through here and start giving some color commentary on what I think will end up making it onto the final. And this is the exact way I write a test. I go through these things, and I kind of have to do it for each class since we kind of extemporaneously create a class. A question I may have asked previously in a different semester won't make sense in the context of this class. So it won't do you any good to go and try to find old exams. is what I'm getting at. At best, maybe you find a reused conversion question or something like that. So having said that, there will be one conversion question on the test. It could be converting from one base to another base. It could be converting from size to another size. I might ask you, you know, how long does it take to download a 3 gigabyte file on a 100 megabit per second internet connection? You should know how to do the math of going between bits and bytes and all that stuff. This should be ingrained in your soul by now. This is something all computer scientists should know how to do. And I stick to my pattern of there'll be one of those on this test. There'll just be one. I'm not going to waste more than one question in here on that, but so that's free 10 points if you know that stuff or an embarrassing situation. All right. Obviously, you should be familiar with the core scheme stuff, cars, coders, yada, yada, yada. I would think that let will be a thing on the exam. I will not ask a question that requires you to use map. But there very well might be a question in there that makes map, a solution involving map would make the question easier to solve. But I won't ask some sort of trick question that, you know, forces you into a map type scenario. Certainly know what a predicate is. I think we ran into that on the previous exam. You know, predicate is a function that takes a single parameter, returns true or false. So if I reference something in a question about predicates, because in a class like this where things are fairly theoretical, I will use the relative formal languages. Like I'll say grammar or production or predicate. These are fair words to use on the exam, so you should be able to, you know, read the question. Obviously be able to write conditionals, know how to write lambdas. There'll be several questions on there where I ask you to write, you know, a scheme procedure that does X, Y, or Z, and I'll try to relate it to something that we did in here from an interpreter perspective, but obviously on a smaller scale thing for an exam, it's going to be probably more of like solve this puzzle using scheme, and maybe it'll be doing something similar to what we did in a question on the, or similar to what we did in our interpreter. Certainly understand the difference between parsing and the interpreter itself. And I know I'm going to get to this later, but just as in my head right now. Certainly the idea of the environment, the variable environment, and the idea of scoping. That's something that we've kind of been doing quite a bit of since the midterm, is the idea of like in our block expression, where we had to have, you know, one question or, you know, one line of code inside of our block potentially had an impact on the environment, which then needed to be passed into the next one. So this whole concept of environment passing, variable scope, things like that, these are, there will be a question involving, at least one question involving variable scope or the environment, probably more than one that'll indirectly involve those concepts. Definitely be is very familiar with lists. I would say just because of the size of an exam, a grammar like this would probably be fairly helpful for you to understand if I want to get you into the mode of something related to languages. Throwing this grammar up specifically might be a convenient base for me to ask questions about. So this is kind of our very early version of our interpreter, where we kind of had three different things, you know, resolve a variable, write a function, and then call a function given an input. I would say outside chance of another question like this. I know this was kind of missed pretty heavily on the midterm. That idea of a variable occurring free or occurring bound. So know where inside of a lambda calculus expression a variable can occur, first of all. And then the follow-up is, does it occur free or does it occur bound? Bound would mean that it's bound to a variable. You know, it was some parameter was passed in or something like that. Free would mean it's just there, and it's based on what I've shown you, it's not bound to anything. That doesn't necessarily mean it's not protected by, you know, or not covered by a more global scope or something, but based on what I've shown you, does this occur free or does this occur bound? So I could give you a lambda calculus expression and say, you know, maybe for like X, Y, and Z, tell me whether X, Y, and Z occurs free or occurs bound. I could say write a lambda calculus expression where a certain variable occurs free and bound, something along those lines. So be able to to do those things. Definitely be familiar with the difference between let star, let rec, the abilities of those three things. There will probably be a question specifically dealing with that. Or at the very least, that a let would make life easier for you, something along those lines. But I could give you some code and ask you what the output is, and specifically use either a let star or a let rec, and you should understand, like, you should be able to look at it and say, oh, this won't work because, you know, a let does not support you defining variables in terms of previously defined variables inside the let, that kind of thing. This is more variable scope type stuff. There's our block expression. Okay, so the kind of leading up to where we are, the pros and cons of an environment passing interpreter, and we've kind of experienced this with our block expression, where when we have to pass things through, we had to come up with a way of making sure that the resulting environment from the previous line was made available to the next line, that kind of thing. And this was because of the nature of an environment passing interpreter. An interpreter where every single time we said, we want you to interpret this next expression, here's the environment in which I want you to evaluate that. As programmers, we might say, oh, wouldn't it be easier just to have an environment sitting out there as this global pod that I can make updates to that environment? And the answer is, when you're adding stuff to the environment, that's probably a true statement, right? But the advantage of an environment passing interpreter is that you can call your interpreter 3, 4, 5 different times, passing at different environments each time. That is the environment in which that particular expression should be evaluated in, and not having to worry about resetting the environment to a past state when you leave a certain scope. Okay, so there are advantages to environment passing interpreters. It's not just, it doesn't only exist to make your life harder. Certainly understand the difference between our procedural language and an object-oriented language. This kind of goes way back to CSC470. And, you know, so one of the things that we've been trying to look at more recently, and we'll kind of close the loop today, is the idea that there is not a major jump between a procedural language and an object-oriented language. We kind of required like two things, right? We need to have the ability for an object to refer to itself from within itself. And we need to have a top level object in which all other objects are built on top of. Now we can say that a third thing might be handy for us to be able to talk to our grandparent, you know, the parent's parent. So typically that's represented as the super keyword, and that sort of supports inheritance. But I would say that gets into maybe a little bit more advanced structure of object-orientedness, where I would say it would be reasonable to have an object-oriented language that does not support inheritance, and you still gain a lot of the benefits of an object-oriented language by doing that. Certainly know that what an object is. It's a collection of fields, methods, and constructors. So this idea of a constructor is something that shouldn't be new to any of you, but it's something that we've just started thinking about in here when we were talking about having an object, having a base object. So we're constructing new objects on top of this idea of what is a default nothingness object. We looked at the example in like Java where we had the object class that knew how to do a couple of things that they've decided that all objects need to be able to do. But regardless of that, I would say that it's fairly rare outside of the toString method in Java that we ever use some of those built-in abilities of the object class. The only reason we would ever use the toString method is if we try to print out an object directly as opposed to just expect its memory address. So even with that, excuse me, even with that, we probably don't have a real common use for the toString method. So you could go on with life fairly easily in Java without ever having the core object class, the thing that all other classes are built on top of, being able to do anything. It just has to exist as that initial building block. It's the initial spark for the rest of the stuff. So understand these basic components that transition from a procedural language to an object-oriented language, and more specifically, why those individual pieces need to exist. So maybe if I'm thinking about this as, what's the difference between a procedural language and an object-oriented language? Kind of know that it's an organizational structure. It's not this giant leap from one language type to this other language type. And then understand the idea of having a variable that knows how to refer to itself from within itself, and then that top level constructor, some object that we can build everything else on top of. So this is object-oriented stuff, but talking about the scoping of variables within that, and this isn't really anything new. So this is variable scoping, works with objects the same way it works with anything else. We just have an extra level of global environment. All right, we talked about the concept of message passing. So how do we call methods? Actually, this is where we stopped in here, right? I think this is our slide, the last slide we had in here. Yeah, so this is what we'll talk about today. I won't give you homework. All right, so having said that, questions about the exam? Anything you want me to go over, review? Good. Each of the lets again, yeah, so. The lets. So we have let, which allows us to introduce local variables that cannot be built in terms of each other. So the example would be like let A equal 5 and B equal A would not be allowed in a normal let. A let star is like a let, but does allow us to build up variables in terms of previously defined variables in the let. So that would be allowed. This does not support recursion. That is to say that if we were to store a lambda as the value of a variable, that lambda would be unable to call itself from within itself recursively, because a let star does not allow it. So something like, let's throw a star in there, let star fact, called factorial, is a lambda that takes an x and then asks x is equal to 1, boil down to 1, otherwise call factorial, or otherwise multiply x times the factorial of minus x1. So that guy would not be allowed in a let star. Let rec is all the features of let star, but does allow us to define functions recursively. So that guy would be allowed. And you could make the argument that, oh, I'll just always use a let rec and I'm just kind of covered. There's probably some truth in that, but that's kind of the idea of bringing a chainsaw to a steak dinner. Something like, oh, I like that metaphor. it's kind of an overkill, but hey, it'll cut the steak if that's what you're looking for. All right, that makes sense.
Yeah.
All right, what else?
I had an additional question.
Sure.
So if the light can't increase local variables, what would be an example?
Well, it can introduce local variables. It just can't introduce variables in terms of themselves. So, you can say, let A is 5, B is 7. And then in the body of it, do plus AB. That's allowed. Yeah, they just can't be they can't be defined in terms of each other inside the let. You could actually kind of pull it off in a let by having nested lets, right? You can have a let A equals 5, and then inside that, the body of that let is another let where B is equal to A. So you can, you can accomplish it. You can make it happen. I don't know about the let rec thing though. That would probably be tough. It probably involves map and time travel. So that'll clearly be on the exam. All right, what else? So we're good for the exam. All right. Anything else pops up? I'm around. I'm not going anywhere. So feel free to ask, but make sure that when you do take the exam, you are prepared to spend, give yourself the 2-hour window, or if you think you're an extra slow test taker and or really like to check your work, like I said, I'll probably put the time limit of 3 hours on there. I do not intend on the exam taking you anywhere close to 3 hours, but the time is yours if you want it. So give yourself as much time as you think is appropriate for you to work on the exam. Make some sense? And with our luck, Blackboard will just be down all next week, and it'll be exciting. What's up? Ah. There, well, yeah, it's kind of the new trend, right? Out of curiosity, what is the student preference? Would you rather have an in-person exam, or would you rather have the exam on Blackboard? Forget about the timing of it. Like, you know, like I do mine where you have the whole week to do it. But I mean, let's just assume you have a set time. It's Tuesday at 2:30. Would you rather have it in class, or would you rather have it online? Does anybody have a strong preference? Go ahead. Okay, so there could be a distraction issue outside of class, which you could solve by doing it, but it kind of gets solved for you by being in class. Because I would say the real reason profs now do it on Blackboard is it's a lot easier to grade. And this is in a good way. Well, I say it's in a good way. It is easier to ensure that Blackboard makes it very easy for me to say, I'm going to grade all of question 1. I already grade stuff with names turned off of, just because, you know, like I don't like you. So, you know, you're losing 3 points right off the bat if I know I'm grading your test, right? You know, we just know that's the truth, right? Okay, so Blackboard makes it easy for me to grade stuff with names off. That's a benefit. I mean, I can try to force myself to not look at the name on the top of a test or something, but you know, you get what I'm saying. But it also lets me grade like all of question 1, just question 1. And that allows me to make sure that I'm kind of treating all the answers to question 1 equally fairly, since there's some wiggle room and, you know, short answer type questions. So I think there's advantages to the grading of it that makes it easier. Plus I can go through and I can grade all of question 1 and then walk away for a day if I wanted to, come back and do question 2 and 3. It's just a whole lot better for the grading side of things. Let's see. Emily likes it online. It helps with test anxiety. Oh, because you don't see other people turning an exam. I see it always sucks when you're working on an exam and you're like 14 minutes in and somebody gets up and turns it in. That was probably a blank exam. I had a prof in my in grad school who his name is Dr. Dennis Devolder. He's the chair of the school now over there. Actually, he's at Western Illinois University now. But he had this thing where a student would come and turn in their test pretty early. And it was never the real test, but he would take another test and he would look at it for a few minutes and he'd get up and he'd rip it in half and go and throw it in the garbage can. So I'm sure that would be great for Emily's test anxiety if the profs ripping exams in half. Go ahead.
I was gonna say though, like, don't let my opinion influence whether
that's a done deal. I was wondering whether or not he. Yeah, no, it is clearly better for profs to have it online, and I do think it's better for students because I think you do get fairer grading. So maybe the one area that it's worse for students, and it would be very specific students, is let's say you're a very good student who always gets A's on things and you're just having it, you know, it's an off week. Everybody can have an off week, right? You're allowed. But when you're a straight A student, you're always getting high A's on exams and things like that. You almost feel like the teacher expects you to get that A when everybody's human, right? Well, I would say it would not be unfounded for a prof to read an answer from a student that they know is typically a good student and find more correctness in it than is actually there. Where if a different student gave the identical answer, the teacher would probably be harder on them because like, oh, this person's clueless. You know, and that's not fair, right? So yeah, I think it makes everything everything better. All right, any other questions about the exam before we jump back into object stuff? Okie dokie. So let's kind of finish up our object example. I think we did start talking about message passing in here, right? We mentioned that phrase, message passing. So we have a couple of different things here. So one thing, and this was what I wanted you to think about for Tuesday's class, is how might we implement our, so this guy here, add to our language the ability to create a blueprint for an object similar to our player 2 blueprint. So player 2 blueprint, I think I kind of had where somewhere up here. Did I say player 2 or person 2? What did I say? I said player 2, so I guess you had to invent something. I think I meant person 2, but whatever. So we want to have a the ability to kind of define this class. And one of the things we mentioned is, okay, we need to have a base class. So somewhere in our code, somewhere at the top, we might have something like define object to be the empty list. This is pretty similar to our empty env. If we go and look at our code right now, up here at the very top. Oh, we already started writing that a little bit. Yeah, so we have this thing called the empty scope. I mean, it's nothing, right? It's an empty list, but it gives us this base for building other things on top of. All right. So in this case, I'll take exactly what we wrote here. So we have this thing called no object. So define no object to be nothingness. All right. So now what we would want to have is the ability to create a class, a syntax for creating a class in our language. And then think about, so really we're saying, what does the syntax look like? Once we have a syntax down, then we can say, okay, well, let's make the parser for it. Parser's not a big deal. That's just reorganizing the stuff. And then what does the interpreter have to pull off of that? So we might say, just to keep things relatively simple, we might have a syntax that looks like this. Maybe we say class player 2, which is technically what I asked you to do. So now when we create a class called player 2, we're doing a couple of different things. So when we think about programming, typically what we do is we define a blueprint, and then at a later point in time, we use that blueprint, right? So if I create a class player 2 here, like this guy here, or person 2 here. Nailed it. All right. So if we have our class player 2 here, right now, these are two separate entities. This is our blueprint that we've defined. Nothing says we ever have to use that, right? It's just defined. Later on, when I actually go and use it to build a player, that's when we're utilizing it. Now, how does, if we just think about it in Java for the moment, how does Java know that there's something called player 2 here? When I write player 2, or, you know, so if I instead put LOL here, Java is going to pretty quickly say, hey, I've never heard of that guy, right? How does Java know that there's a player two? Where does it look? Go ahead. Okay, so if we're thinking about Java, those other files are where we're defining it. But you think Java is actually looking at files directly? So is Java going and scouring your file structure, looking for it? And if it doesn't find it there, is it then going and looking at more global file structures? I mean, we could say maybe, that wouldn't be unfounded, but typically not how languages would actually work. So where does it find that there's something called player two?
Like everything would be, like once it's run initially, everything will get its own memory address, and then maybe player two looks for its memory address.
Okay, when you say it gets a memory address, what do you mean? What are other things that get memory addresses in our languages?
Well, various things, like there's probably, I don't know specifically, there's probably memory address for like variable or string.
Just probably. Yeah, anything that we need to remember is going to have a memory address associated. It might not expose its memory address to us, but it's stored somewhere in memory, right? That's how computers work, right? We want to remember something, we're going to put it in memory. Great. So when we create a blueprint, isn't this stuff here? Isn't that the value of a variable type called player two? At the very least ish, right? So if we define a blueprint, we would put that inside of our variable environment, or at least that would be a reasonable place to put it into our variable environment. So we can say, we're going to define player two to be a class. And just to keep things simple, because I think my version of player two right now does nothing, right? Yeah, it does nothing. All right. So we can say we want this guy to be a class. Now, what are the things that all objects have in them? What are the three types of things that classes contain? Go ahead. Okay, fields, constructors, and methods. All right. So we could say it would be reasonable for the class constructor here, for this guy to take in maybe a list of fields. And maybe in this case, I give it 0 fields. I can take in a list of constructors. In this case, give it no constructors. And in the case I give it no constructors, we would assume it's a no argument constructor that does nothing. And I can take in no methods. So I'm effectively defining a plain Jane variable called player two, whose value is this syntax. It's a class. That's the kind of animal this is. And classes have fields, constructors, and methods in it. All right. Now I could expand this a little bit. I can say something like we have a field called name. And then we have a constructor. And constructors kind of come in the form of, they look like lambdas, right? So I can say one of our constructors is a lambda that takes in a n here for our intents and purposes, and would do something like, actually for our, how did we rate functions? Did we rate functions yet? We did. We didn't call them lambdas. What did we call them? We do all these Spit out, do Matthew stuff. Oh, a call expression. Thank you. Although call expression actually applies actually calls a function given parameters. I want to store just the function part of it. So I want really this piece of it. Okay, in our example here. So here we're going to call this guy a func. Now we could differentiate between the two. We can say that we have things that are constructors and things that are functions. And maybe we say that that's an okay thing. The way I have it written here is I'm flagging these functions as constructor types, and then I'm going to flag the next things as method types. So then we can decide that we're going to store them differently if we want. So in this case, why don't we say, we'll make everything a function, and we have n. Now we definitely have the ability to set some variables. We have our example here, right? We call it remember. So we probably want to have remember creates a new variable, right? We probably want to have the ability to update an existing variable. Do we have that ability yet? Doesn't look like we have that ability yet. So we can put something in here like update this name. I'm just kind of randomly doing things. And this is allowing me, and actually just to really drive the point home, I want this function to take a name as a parameter, and the body of this function is going to call something called update. And this guy is the variable that we are updating, which is name, but the one specifically belonging to this. So we have to have some sort of way of jumping all the way to the top level of what this guy is. So we have to have a syntax for being able to say effectively this dot name, that type of thing. Because I want to have this class's field be equal to the value that was passed into this function. So we could say, oh, we'll just call this guy, maybe the field name is equal to a method. That then takes away our ability to reference this for function calls. So just to keep it similar to our modern languages, since we're kind of in our last home stretch here, we'll just say this. So we're going to set this name, and we're updating a variable, equal to name, the most local definition of name, which is the thing that was passed in here. Name occurs and it's bound right here. Okay. And that is what this constructor will have in it. So a constructor will be a list of functions. In this case, I have one constructor that takes a single parameter and sets this guy's name equal to the value that was passed in. That's my intention for that. All right. And then for, I think we do have a display, don't we? Spit out our display. I think it is. So for methods, I can have a func that takes no parameters. We actually have to have a name. So we'll say display is a func that takes no parameters and spits out this name. That ends that. That ends that. That ends that. That ends that. that is that. Something like that would be our syntax for defining our player2 class. So player2 is a variable. Its value is a class type. So this is our syntax for how do we talk about this guy right here. This is a generic class. It only is associated with a name called player2 because we're defining a variable called player2. Or I think in our example, we say remember, right? I think ours is remember. Remember player2 is this value. So we have a new kind of value, a thing that is a collection of fields, constructors, and methods. Make sense? Okay. A little bit, you know, we could spread this out a little bit if we were writing it. So, but this isn't anything majorly different than what we've had before, is it? This isn't a major new implementation style or anything like that. We've just created a new thing that allows us to hold 3 lists of things, right? List of fields, list of methods, and a list of constructors. All right, so this is how we might create that blueprint. Now, how do we create an instance of that blueprint? That's what we're doing back here, right? When I say I want to create a variable named P, and I want it to be one of these guys. So this is where we get into that message passing thing. Well, P is a new variable, right? And where do we put variables? We put them into our variable environment somewhere. And how do we remember new variables? We use our remember. So now we maybe create a remember. We'll say P in our current example. Okay. And we want P to have a value. All right. So now we have to have some way of saying P is an instance of this guy built using one of these. Because we always build instances of objects using a constructor. But it doesn't have to be a specific constructor. It just has to be one of our constructors. Now, we could, in our first version of our object-orientedness in our language, we could say that every object gets a single constructor. There's only one way to build an object. And I don't think that's necessarily a horrible idea for us to just consider right now. That way we don't have to go and hunt down which constructor are you calling based on the parameters you gave me. We could. That wouldn't be the end of the world if you're just looking for a function that takes 1 input rather than 3. We could certainly do that, but we can just assume that our, maybe this guy is just constructor. That's how you build a player2, is through that one constructor. You could have multiple fields, you could have multiple methods, but you get one constructor. Not a deal breaker, probably. Okay. So we can say, remember P, and now we have to have a way of, we want the message that we want to send our interpreter is that we want to do something. And what we want to do is we want to create an instance. So we can say create instance. Now, when we create an instance, we have to say first, what is the blueprint we're going to use? And the blueprint we're going to use is stored inside of a variable called player2. So that's the blueprint we're going to use. Now we need to pass it. We need to call the constructor, right? So now we need to say, what are the inputs? Because in this case, I'm assuming, I'll just put a little thing, assuming there is only one, let's see, assuming our language supports a single constructor only. I think it was just hanging there. It's not important. Because it's supposed to be plugged into an outlet somewhere, so these things go up and down. That's part of our, the hope is that the whole department will be redesigned by next fall. we're getting a quote for like redoing everything, floors, furniture. The idea is for it to kind of look like Google, to have like elevated things with study areas, and we have to see how much it costs and who's going to pay for it, but we're paying for the design. We'll see what happens with that. You know, we'll obviously have the elevated hot tub back there. We're probably going to get one of those skydiving things. You know, it has giant fans. It'd be pretty creepy, actually, that, but have a hot tub in there.
Yeah.
Any of you ever been on one of those skydiving things? Where, you know what I'm talking about, though. It has the giant fan, and you know, so they have them on. It's one of the newer things they have on cruise ships, and so there's a lot of things like the zip lines and stuff like that on the cruise ships that they don't let me on because, you know, I'm too short. But they did let me into the sky. The fan couldn't. It was pretty funny. I mean, but I'm kind of used to having a good sense of humor. I mean, you're a big guy. Like, look, just accept it. You know, this is the way it is, and you know that fan wasn't built to push that kind of weight. But yeah, it didn't even move me at all. It was really pretty impressive, actually. I hit the buffets pretty hard during that cruise. So it was, well, it's a giant fan, like it's a wind tunnel.
Yeah.
Most people would have expected it to move me, especially since I'm providing quite a bit of like surface area for it to push against. I'm telling you, these cruise ships, they're cutting corners. They didn't bring enough horsepower in there.
Well, maybe you should find a new design and buy a cruise company that make it.
It's a lot cheaper to just pay for the cruise and go on there than buying your own cruise company.
You may buy your business.
I could afford to do it. That's not the problem. I've seen that happen in real life. There's with our a lot of country clubs. The club I'm at is River Club over here, and the previous owner, you know, was a multimillionaire type guy and liked golf and decided, oh, I should own a golf club. Well, those are two very different things. And he put a lot of money into it. I mean, you know, he rebuilt the clubhouse, all this really cool stuff, but the place kept bleeding money. He shouldn't have been in the hospitality business. Go golf. You pay somebody else's club your $20,000 a year and go and golf and enjoy yourself. You don't have to own a golf club and have to deal with employees and all those other things. Let somebody who's, you know, a property management group or something like that, who they're in the business of doing that, let them do it. So I'll let them upgrade their wind tunnel themselves. I'll hang out at the bar. I'm happy enough. It all works out. My wife was too afraid to do the wind tunnel thing, so, and it would have probably blown her into the wall. I have a pocket wife. I don't have to buy her own airplane ticket. I bring her into my carry-on and could stuff her in the overhead. Well, that's just cruel. And shoving her into the overhead's not.
Shoving her anywhere is not.
Well, she was just going to sleep anyways. And she does. She sleeps like instantly on an airplane. So we fly places, and you know, we fly business class. You got these nice comfy seats that are, you know, and then full service people coming around. No, she's just out cold before the plane even takes off. And you got to wake her up when it lands. That was a waste of money. I mean, she didn't need a ticket. Overhead would have been fine. I'm positive there's laws or at least regulations from the airlines.
If she went to Africa, maybe not.
Yeah, some kind of airline there.
Airline
in the Congo.
Yeah, you might be able to get away with that.
Hey, all the movies show that if you're taking off out of an airport in the Congo, that plane never makes it. It always gets shot down by somebody. It's just, that's just
Oh,
not,
maybe you should take it to test that theory.
yeah, there's too many bugs there. My wife's not a fan of bugs. I would check out the Congo. I'm gonna go on a safari. All right, so we want to create an instance of our guy here. So we're going to remember a variable. This is no different than remembering any other kind of variable. We're going to remember a variable called P, and we're going to give it a value. And what's the value of this guy? All we're doing in our language is we're just creating a new kind of value. So we're going to create a value that is going to contain everything that we need to create an instance of our player 2. So this is our blueprint. So the assumption here is that this guy will be a class type. So that's our blueprint. And then we also then need to give it enough information for it to create for the constructor. The constructor for this guy takes in a name. So I'll go ahead and just give it the name Mike. So that's the input. This constructor for this guy takes a single input. We can give it as many inputs as we might need. So, we've done that before with our call expression, right? We can have as many inputs as we need. So this is really no different than our call expression. We're just flagging it as, hey, this is actually creating an instance of something, whatever that means. And that's it. So now I've created a variable named P whose value is whatever this guy boils down to. Our create instance of player 2 and Mike. So then we ask ourselves, well, what should that boil down to? What should create instance actually do for us? What is an instantiated object? I'll put in another slide. What is that guy? What is an instantiated object? You want me to give you some additional context? P is an instantiated object. P2 is an instantiated object. What's different about them? Go ahead. Okay. Let me update this guy just to make it actually match what we have here. So I'm going to say string name. This guy will take in a string name as a parameter. And we'll set this dot name equal to name. And then we also had a void display. All right, so this is what our actual thing is. So let's do this is Mike. This is Dave. All right, so we have two separate instances here, both built using the same blueprint. Our constructor for that blueprint takes in a single string as a parameter. So what's the difference between P and P2? So you mentioned that P has a variable name that's equal to Mike. P2 has a variable name that's equal to Dave. Where do we store variables? Where do we store it in the context of our programming languages that we have, our interpreter? In an environment. So is it true that every new instance gets his own environment, or at least his own scope, right? He has his own scope. Does he also then have access to the other things that are inside of the current scope that he lives in? Sure. So I'm lost. An instantiated object is a collection of name value pairs. It's an environment that extends the current accessible environment. We have called this scope. So we would create a brand new scope. Inside that scope, we would say name is equal to Mike for one of them. We'd say name is equal to Dave for the other one. And that guy would extend the environment that each one of those guys currently had access to. So housed inside of I keep getting lost in here. Here we go. Housed inside of P so inside of our scope, we would have a variable P. I don't remember how we represented our scope, but whatever. So inside of our scope, we would have a variable named P whose value would be equal to, so name is Mike. Let's just put some dots in there for right now. And then if I wanted to create a separate, a second instance here, call this guy P2. This is Dave. So we'd have P2 name Dave, something like that. That would be the end of that scope. And then I think I think I labeled it global scope, something like that. So our updated variable environment from P's perspective would be actually from P's perspective. From P2's perspective, and actually, well, here. All right, so from the current scope, so maybe this is inside of a block structure. From the current scope, we've extended our environment with two new variables in the current scope, P and P2. P has a name is equal to Mike, and then it might have some other stuff. We have to decide what that looks like. P2 has a name is equal to Dave, then it might have some other stuff. We have to decide what is an instance of a player to look like? How should we represent that? All right. But now we just said that both P and P2 have their own scopes, right? They get their own scopes inside of P here. He knows about his name is equal to Mike. P2 knows that his name is equal to Dave. Does that make sense? All right. So the scope associated with P would look something like this. And the scope associated with P2 would look something like this. And notice that P doesn't know about P2. P2 doesn't know about P. But also notice I put little question marks here. So inside of P, what does his scope look like? What's that variable name? From P's perspective, does he know about a variable called P? What does he know about? He knows about himself, a variable called this. From P2's perspective, does he have a variable called P2? Nope. He knows about himself, this. So that will allow us inside of like the display method that we might put in there inside these dots for it to spit out this dot name. That makes sense? So really, the difference here between a procedural and an object-oriented language is how we use the environment. And we didn't really have to change our environment. We just added a new type of value that we stored in the environment, and we get to choose how we're going to store it. Collection of 3 lists, one for fields, one for constructors, one for methods, and then decide how do we represent instances. We just come up with some sort of proprietary structure for representing instances like this. And now you have an object-oriented language. Make some sense? All right, questions, comments, concerns, bribes. All right, I'll see everybody around whenever I see you. Remember, last night of senior seminar presentations is tonight. We actually have, what, 2 classmates tonight presenting? You're presenting and Jason's presenting. Anybody else from this class?